Morning. As Liz says, I am here to talk about introducing Kubernetes into an existing large containerized stack. We often give conference talks as though we're talking about a journey, as though we had a destination and we set out and there were a few problems along the way and we got there. I don't think that's really how it works, because we might have some idea of where we want to go. We've got this picture of a city with the streets paved with gold, but we don't actually know where it is. But more importantly, we don't start out from home. It's really rare to start a project from scratch, and even when you do start a project from scratch, very soon you're carrying lots of baggage, the decisions that you've made along the way. And those decisions are made for the right reasons, but they can come back and hurt you later when you make some other change. So, as I said, I work for the Financial Times, and we're one of the world's leading news organizations, and we don't describe ourselves as a newspaper, because most people who read the Financial Times do that online, which means technology is really critical to us, to our success. And a couple of years ago, we decided to give teams a lot of power to make their own decisions about technologies they use, which means we have a very diverse stack. They use very different technologies, but I'm going to talk about one team in particular. And this is the content platform. So the FT's content platform, it's a very simplified view. We take content from multiple source content management systems. We transform it into a common format. We have lots and lots of concepts that we load into our system, companies, people, topics, and we annotate that content. So we can say this article is about Apple. It mentions Tim Cook. And then we make all of that information available through APIs. But this is what it really looks like. I don't expect you to see the detail. That's actually the point of this slide. It's a really complicated architecture diagram because we've got a microservice architecture, and boy, have we gone for that. It's 150 microservices. It's around 650 instances running in production. And in those circumstances, migration is not a small thing to attempt. So the first question is, why did we migrate at all? Well, we started running Docker in production in mid-2015. And I'd say that at the time, that was pretty leading edge. I mean, there were things you could use, but you probably had to do quite a lot of work to glue them together. And I know Simon Wardley's speaking at KubeCon tomorrow. His work on value mapping is fantastic. This is just talking about the maturity curve for technology. Things start off as being something for experts, and you do custom builds for it. But as it becomes more ubiquitous, people start building products, and finally it becomes a commodity. And a great example of this is electricity. We don't build power stations now. We just plug something in. And a more recent example would be about computing. I'm sure lots of companies here did what the FT did, which is have their own data center, then build their own private cloud, and then move to a cloud provider. So in 2015, Docker and associated technologies were definitely closer to the left-hand side than the right-hand side of this. Etsy talk about innovation tokens, the concept that there's a limit of the amount of innovation you can do at any one time. I mean, it's not really a limit, but if you want to be successful, you should probably try and limit it. So you have to imagine you have a couple of tokens. What are you going to spend them on? You want to use a new database that no one's used before? You're spending a token. I think building your own container cluster orchestration is definitely spending an innovation token. So why did we do that? Well, because the benefits outweighed the risks. Before we did this, we were running every microservice in its own VM, and that's pretty inefficient because you don't use up the CPU or the memory of even the smallest VM. We ended up running our entire stack on 8 extremely large VMs per region, as opposed to 300 plus small VMs. It's about an 80% cost reduction. But it's not just the reduction in costs. Because before we did this migration, we'd have to set up those VMs, and we have 2 instances in each region in production, 2 regions, staging as well, development. You'd basically go through the process of provisioning a VM 12, 16 times. And even if that's a very short amount of time, it adds up. And now, after we'd done this, we just created a single service file and listed that service in a YAML directory, effectively. But the gains you get can be offset by other things. If you build it yourself, you've nowhere else to go for help. Documentation, particularly in terms of decisions that were made and why, is very rarely a priority. And in our case, most of the containerization work was done by a core group of people pretty much all of whom left the FT in a couple of months in 2016. And when that happens, you're supporting stuff that you don't really understand and you can't ask anyone. So the concept of innovation tokens is actually mentioned in this blog post from Dan McKinley as the flip side of using boring technology. And boring doesn't mean bad. Boring technologies are things that lots of people are using successfully, letting them get on with focusing on the stuff that's a differentiator for them as a company. New and innovative technology, although it's exciting, has capabilities that you probably don't understand, and in particular, the failure modes are not likely to be well understood. You really want boring in software that you're operating. So by late 2016, we could see that tools were maturing. So 2015, we didn't really think we had a boring alternative to choose, but by 2016, we could read stories about people successfully doing things in production. And we felt that things were moving up through this maturity curve. It's important to take advantage when things move up of this. You don't want to be maintaining something yourself once it's available as a product, unless it's something that's absolutely core to your business. The FT is not a cluster orchestration company. We are a news organization, and that's where we should focus our innovation. So in late 2016, we had a workshop, and we started thinking, well, what could we use? What should we move to? And the first thing we did was decide some metrics for the success. We spent quite a lot of time keeping our cluster healthy. We had a lot of resilience, so actually it didn't affect users of our cluster, but it's painful for the people that are doing that. And actually, a very good metric for developer satisfaction is how many sarcastic comments they're making in Slack. Because they won't necessarily complain to you all the time, but you'll see it. We opted for Kubernetes. Two reasons. First of all, we preferred it to the other things that we assessed, but secondly, we thought, this is looking like it's going to be the emerging standard. And we kind of had a big appetite for being able to ask other people what they were doing. And then in February of 2017, I saw Lizzie's poll, and I thought, yeah, I think we're making the right decision here. I think we actually are pretty comfortable with having been taking advantage of some leading-edge technologies, because you can very much benefit from it. So when we went to microservices, we moved from doing 12 releases a year to doing 2,200. And they were much lower failure rate as well. But you had to be prepared to stop and say, is it time to give up on this? We tried something innovative, it doesn't work. Or is it time to move to the product that's now available? And I think you should expect that, and you should build that into your plans for your work. But I don't think you should be too scared about making the wrong decision if you're picking up something new. And Jeff Bezos says that there are two types of decision. Type 1 is not reversible, and you have to be very careful when you make it. And for the Brits in the audience, I think Article 50 is a Type 1 decision. Type 2 is like walking through a door. You can always go back. And Bezos says people often use the heavyweight decision-making process for Type 1 for all kinds of decisions. You can actually just decide to do it and then change your mind. But even having good reasons to do this migration and feeling quite happy that we should do it is still a major challenge. You are trying to change horses in the middle of a roaring river. You have a lot of other stuff going on. At the start of this migration, we had 150 services running live in production and under active development. When I say active development, this is an attempt for us to work out the dependencies between different teams trying to do work on our stack in 2017. So the migration team had to try and do the migration without affecting all of that work. If you're building something from scratch, you can quite easily build up a little trial platform and put a few services in it. But the things that we really wanted to understand whether Kubernetes worked for us, we needed a lot of our services to be running. So there's things around replacing our host-based routing. And that meant we had to run in parallel. And we ran in parallel for quite a long time. Did about 2,000 code releases while running at least part of the stack in parallel. If it takes an extra 10 minutes to do the deployments to both of those stacks, that's actually 47 working days to do all those releases. So, you pay a cost when you're running stuff in parallel as soon as you have a lot of services. And then we had to make some decisions about how we were going to run in parallel. We started off by thinking about how are we going to commit changes. And in our proof of concept, we had our Kubernetes changes on a separate branch. And I'm sure anyone that's ever been stuck in merge hell will realize that that's a bad idea. We very quickly decided that that was just going to diverge too much and it would be too painful to try and maintain it. So we said everything has to go onto the same branch. But that means you now start deploying changes to your live stack purely to support the fact that you're building this other stack. So that is a risk. It's a risk, and you have to decide whether you're okay with that risk. The second thing was around deployment. If you have completely separate deployment mechanisms for two stacks, you can absolutely guarantee things will get out of sync because someone will forget to do the deployment for one of the two. And if you've got 150 services, it's actually quite hard to scan and see that you're out of sync. But running a single pipeline is risky because you don't want to block an emergency deployment to your live stack because someone got something wrong on your new experimental stack. So in the end, we kind of compromised. Both deployments were kicked off by tagging a release in GitHub. Deployments to lower environments were done automatically, and we had a push button, OK, go, policy for putting it to the Kubernetes stack. And then we wrote a service that would basically compare the versions and report on the differences. And we just ran that manually every couple of days and then said, look, you forgot to deploy this. Testing is another area where you can get really sucked in. You don't want to have to test everything in two places. So we focused on the live stack. We did very little testing as we went on the Kubernetes stack, but we had some things that really helped us here that we'd built for our staging environment, and we just used them now for the new stack. First of all, we had every event about publishing content that goes through our production stack, we can also send it off to any other place we want. So every publish went to both, and that meant that if it failed, we would know immediately, because we have monitoring for every publish to say, did it make it through the whole stack? And secondly, we have a load replicator that replays API requests, and we could play that against the new stack. So we knew if we had a problem there with something not quite working. And then at the end, we did a big end-to-end testing effort. So running in parallel is costly. Second thing I wanted to talk about was just the fact that you have 150 services. Doing anything 150 times, it takes time. So let's say that it took 30 minutes to migrate a service from our old stack to the Kubernetes stack. Well, that's 10 days of work. But the changes per service weren't that big. We were pretty confident. We're just basically migrating from systemd service files to using Helm charts. They were all very similar. It didn't take very long. And we had a small amount of hook-in code to be able to deploy to a templated Jenkins pipeline. And to avoid having a single team working for days and days and days on the same repetitive task, we got everyone from 5 development teams involved in this, and we had Helm Day. So every single person basically migrated some services. And this was great because you want everyone on your team to understand the technologies you're moving to and have a chance to give you feedback about them. The problem was it wasn't a Helm Day, it was Helm Days, because we discovered a lot of broken things. Several reasons for that. You always have bits of your code base that change a lot and other bits that don't. But in microservices, that ends up being some service that hasn't been built or deployed for ages because it has just worked. And then when you do need to make a change to it, you have to build something that's not been built for 2 years. And that is particularly bad if you wrote the service in Go, didn't have vendoring. And so you're picking in 2 years' worth of changes that have happened in any libraries that you depend on. We now have vendoring in all our Go apps. But we had to do that as part of the work. So we've improved our code base, but it was painful. One of the other teams in the FT actually builds every service every night. They don't deploy it, but they build it. And I think that's probably a wise idea, because if you suddenly have to do something like this for security reasons, you really don't want to have to spend ages fixing everything up. We're lucky enough at the FT to have a very widely complied with health check standard. So almost every service has an __ health endpoint that will say, I am healthy, in a well-known JSON format. And we use that to have an aggregation service that can tell us the health of the entire cluster. We rewrote this when we moved to Kubernetes, and we rewrote it taking into account all aspects of the health check standard, but it turns out that we've never previously cared whether the health check timed out within 5 seconds. And we discovered that, as a result, quite a lot of our services didn't do that. And that meant that we'd have things reported as being down when, in fact, they were just slightly slow in telling you whether they were healthy. So we had to change that. And that's another improvement, but it takes time. Similarly, we have a good-to-go endpoint, and we thought that's great, we can use that for the readiness probe. In the previous stack, we don't use it at all, which means we found quite a lot of services didn't have it, and what was worse, quite a lot of services had it, but it returned a 200 regardless. So traffic always went to the service. So again, we had to fix that up. And this is just, unless you're using it, you don't necessarily know that you've got it right. The final thing was actually caused by lots of our services having been written before we'd containerized at all. So, we are a big fan of 12-factor apps, but before we were in containers, it didn't matter if it expected the database to be there. With our previous stack, things didn't get moved around that much, so we could kind of get away with it. But now, Kubernetes is moving services around all the time, and you need your services to be able to recover if the things they depend on aren't there. So we had code changes to do for that. But the final comment on this is that developers don't like to leave something in a bad state. And if you pick up some code that you wrote 2 years ago when you were just learning Go, and you're just supposed to be fixing some stuff up, actually you want to fix everything up and all the stuff you've learned in the last 2 years. And all that happens is you say, have you finished migrating that service? And the developer says, yeah, nearly. And you can just get sucked into making everything better, and it takes a long time. So there are lots of small things that we could have done differently. But the major thing that I would change if I did this again is I would have tried to do it all together. Because we had a very, very small team working on this. And it's very hard on them because they're doing a lot of repetitive work over months and months. It's also the overhead that you pay when you're releasing stuff to 2 stacks. And the higher the costs. So running in parallel increased our AWS costs, which is fine. We were allowing for that. I do recommend mentioning it to the people who pay the bills before they get a chart like this. I think it caused some surprise. It's not just AWS costs. Because we were running our load replicator, we had a lot of access logs, and we were sending them to our log aggregator. And sending twice as many logs didn't make us very popular. I believe we may have blown the license limit a few times. So how did it all go? Well, we went live just before a key part of our old stack went end of life. Technically, probably a couple of days after it went end of life. The last few months were quite intense. We had to get everyone involved, but that was good because it felt like we were really invested in this new platform. The migration went very smoothly. The interesting thing is everything that went wrong in the migration was because people were using our stack in ways we didn't understand. So we had a small bug with one of our APIs where we weren't complying with the HTTP spec. We thought it was fine to fix that up. Turns out clients were relying on the fact we weren't complying with the spec. And we've got some really well-defined integration points. So if you publish, you hit a particular URL. If you come into our APIs, you come in through an API gateway, except the people who weren't. And the only way you can find them is when you migrate stuff, and then you look at what load you've still got on your existing stack, and then you try and work out who that might be. But actually, this took so little time to fix, and it was incredibly smooth. And in terms of the results, did we get the results that we were looking for? Yes. System stability, we had 3 production incidents. And when I say incidents, it didn't affect anyone. We just had some nodes going down in the month after we went live compared to 17 in the same month in 2017. We've had 2 out-of-hours calls. In both cases, Kubernetes has recovered the system before the developers even opened their laptop. And I actually haven't seen any complaining in Slack about the new stack, which I think is a major achievement, because I don't think it's really rare to have a developer not complaining about something. I don't know if anyone does the Spotify team health checks, but I've never seen a developer happy about the health of their code base. And we have something we can learn from others. We can go to conferences, we can watch talks, we can talk to other companies, and we can send people on training, which we couldn't do when it was our own stack. And actually, hosting and support costs are cheaper compared to our old stack and several of the alternatives. We break even in 3 years, pretty much. So that wasn't the major reason for doing it, but it's also a good thing. So that was our journey. We didn't start from the easiest place. And the interesting thing is we probably didn't end up where we thought we were going to go. And I think it's a good thing to stop occasionally and say, is this a good place? Maybe we could pause here. We have a much more stable, cheaper system and a happier team who are able to spend more time on functional stuff, rather than supporting our platforms. So I believe I'm just going to take the opportunity to say we're hiring in both London and Sofia. So if anyone's interested, feel free to come and talk to me. Thank you.